Hey guys, welcome to day 20. Today's concept is converting from moles to grams, but this time for compounds. We've done this in the past for elements, and we've just simply used the atomic weight from the periodic table, but now we're going to do this for compounds as well, and we know that with compounds we need to calculate the molar mass of the compound first. So for the first example, I want to convert from moles of water to grams of water. Now, before I need to do that, I have to get the molar mass. So MM stands for molar mass. Now, if you look at the formula, H2O, we have 2 atoms of hydrogen. So I have to take the molar mass of hydrogen and multiply that by 2. And the formula includes 1 oxygen atom, so 1 oxygen atom is 16 grams per mole. So the molar mass of water is 18.0. If you guys are going to 2 decimal places, it will be closer to 18.02. Okay, so I guess the next thing that I want to do is I want to convert from moles of water to grams of water. So moles are going to go on the bottom, and I can show unit cancellation, and I want to end up in grams, so I'm going to put that in top. And remember, guys, most of the time the 1 goes with the moles, and in this case the 18.0 goes with the grams. Okay, so get your calculators out, and I'm going to multiply 6.20 times 18.0, and my calculator gives me 111.6. But let's talk about sig figs real quick. We've got 3 sig figs there, 3 sig figs there, and don't let the 1 limit your sig figs. So with the appropriate number of sig figs, I'm probably going to call this 112 grams. Final answer. All right, let's do another example. This time we are going to go from grams of calcium hydroxide to, let's see, we're going to go from grams to moles, and I realize there's a little typo over here, so we're going to go to moles of calcium hydroxide. All right, so the first thing that we need to do is we need to get the molar mass of calcium hydroxide. So there is 1 calcium ion in this particular compound. So I looked at the periodic table and calcium is 40.1. There are 2 hydrogens. 2 times 1 hydrogen would be 2 times 1. And there are also 2 oxygens. So 2 times 16 would be 32. So 40.1 plus 2 plus 32 equals 74.1 grams per mole. So step 1 is we got to get the molar mass. And step 2, we want to convert from grams. So if we want to cancel grams, we're going to put that on bottom. We want to end up in moles, so we're going to put that on top. So 1 mole of calcium hydroxide is about 74 grams. So get your calculators out, and you're going to do 325 times 1. And then we're going to divide by 74.1. And my calculator gives me 4.3859, and it keeps going on. But sig figs, we've got 3 sig figs on top. We've got 3 sig figs on bottom. I believe that we can keep 3 sig figs. So let's call this 4.39 moles. Okay, so grams of calcium hydroxide to moles. All right, the next example is a little bit more tricky. This time we are going to go from grams of methane to hydrogen atoms. And before I do that, if I take a look at methane, methane is a molecule that contains 4 hydrogen atoms, and that's going to be a conversion factor for us. So 1 molecule of methane is equal to 4 hydrogen atoms. So that's kind of a conversion factor that I had to come up with in the beginning, but beyond that, we're just going to do it the same way that we've done it in the past, okay? So step 1, we want to go, and guys, I'm going to outline this for you real quick. We are going to go from grams of methane to moles of methane. From moles of methane, we're going to go to molecules of methane, and then from molecules, we can go to hydrogen atoms, okay? So grams to moles, we're going to use the molar mass. Moles to molecules, we're going to use Avogadro's number. And molecules to hydrogen atoms, we're going to use this conversion factor that we just constructed. So step 1, we're going to go from grams of methane to moles of methane. And I'm not going to go through my calculation because I've done that before, but 1 mole of methane is about 16 grams, okay? And we're going to show unit cancellation along the way. Then we're going to go from moles of methane to molecules of methane. I'll show unit cancellation in a different color. So moles cancels out moles. And then we're going to go from molecules of methane to hydrogen atoms. And that's the conversion factor that we constructed down below. Okay. All right. While I'm here, I'm going to zoom a little bit. 1 mole contains Avogadro's numbers of molecules. So we're going to multiply by Avogadro's number. I think I did forget to show unit cancellation on molecules, so I'll do that now. So molecules are going to cancel out molecules. And we said that 1 molecule of methane contains 4 hydrogen atoms. So all in all, everything cancels out, and we should end with hydrogen atoms. So in our calculators, we're going to start with 87.3. We're going to divide by 16.0. We're going to multiply by Avogadro's number. And then we're going to multiply by 4 because there's 4 hydrogen atoms in every 1 molecule. And I'm not going to go into sig figs, guys. Just a side note that this is an exact number of atoms per molecule, so we're not going to limit sig figs using that. I am going to keep 3 sig figs, and my final answer is going to be 1.31 times 10 to the 25 atoms. Okay, guys, I'm going to stop the video here, and then I'm going to make a separate video for some of the problems down below. And if you have any questions, don't hesitate to leave me an email or a message. I love you guys. I miss you guys. I'll talk to you soon.